Hello students, so we're going to go over some basic information in section 8.4 and then do at least one example in this video. If we don't finish that example in this video, we'll go ahead and finish it in the next video. Okay, so section 8.4 is about hypothesis tests on the difference between two proportions. Okay, and section 8.4 begins on page 447 of the book. So this is some of the notation that you're going to see in this section. So x1 and x2 will represent the number of successes in samples 1 and 2 respectively. N1 and N2 will represent the sample sizes of samples 1 and 2. P1 hat and P2 hat are the sample proportions from the two samples. And then likewise P1 and P2 are the population proportions from the corresponding populations. So when we do hypothesis tests for one proportion or two proportions, okay, remember we are studying or looking at the proportion or percentage of a sample or population that has a certain characteristic or who hold a certain belief. Okay, so the null hypothesis will look like as follows, right? So P1 minus P2. So the difference between the population proportions, okay, will either be less than or equal to, greater than or equal to 0. Okay. So in other words, one of those three symbols will replace the question mark in the null hypothesis. Okay, likewise, the alternative hypothesis will look like P1 minus P2, where we will replace the question mark with either the less than, greater than, or not equal to symbol. Okay, so if the number of successes in each sample is not given in the problem, okay, then you're going to use the following formulas to calculate the number of successes. Okay, so essentially, if you want to find the number of successes in sample 1, you take the sample size for sample 1, and then multiply by the sample proportion. So this should be the sample proportion, not the population proportion. Okay, likewise, to calculate the number of successes in sample 2, right, you take the sample size of sample 2 and multiply by the sample proportion in sample 2. Okay, and keep in mind that the sample proportions, okay, must be expressed as decimals when you use either of these formulas. Okay, so if P1 hat and P2 hat are given to you as percentages, right, convert them into decimals, and then multiply by the corresponding sample sizes to get the number of successes in each sample. And then round the number of successes to the nearest whole number as necessary. So I went ahead and updated the formula. So once again, if it's the number of successes that you're looking for in each sample, right, you're going to use the sample proportions that are given to you in the problem, and remember to convert them into decimals before using these formulas. Okay, so we're going to go and look at problem 2 from the homework in section 8.4. And the problem says, in a survey of 175 females who recently completed high school, 72% were enrolled in college. In a survey of 150 males who recently completed high school, right, 60% were enrolled in college. Okay, so at a significance level of 0.09, right, can you reject the claim that there is no difference in the proportion of college enrollees between the two groups? Okay, and we're going to assume that that the random samples are independent. Okay, we can see that because the number of females in the survey is not equal to the number of males in the survey. So these two samples are definitely independent. Okay, we're going to complete parts A through E. Okay, so the claim in the problem is that there is no difference between the percent of females enrolled in college, and the percent of males, enrolled in college. From the population of all high school graduates. Okay, so I added that last part there. Okay, so it's understood that we're studying, okay, high school graduates who are enrolled in college. Okay, that's understood from the problem. Okay, so there's no difference between the percent of females enrolled in college and the percent of males enrolled in college from the population of high school graduates. Okay, so that's the claim that was given to us in the problem. Okay, so since we're dealing with two different populations, right? The population of female high school graduates and then the population of male high school graduates. Okay, then P1 will represent the proportion of females. So since the females are the first group mentioned, okay, so P1 will represent the proportion, okay, of all female high school graduates, okay, who are enrolled in college. Okay, and then likewise, since the males are mentioned second in the problem, okay, so P2 would be the proportion of male high school graduates, okay, who are enrolled in college. So keep in mind that proportion and percentage will sometimes be used interchangeably. So when we say proportion, okay, we also mean percentage. Okay, so P1 is the percentage of all female high school graduates who are in college, and likewise P2 is the percent of all male high school graduates who are also enrolled in college. Okay, and for obvious reasons, we don't know what these are. We don't know what these percentages are for the entire population. Okay, so that's why we've collected a sample of randomly selected females and then a randomly selected males to help us answer this question about the entire population of high school graduates. Okay, so now we're going to go ahead and set up the null and alternative hypothesis. Okay, so remember we're looking at the difference between these two proportions in the problem. Okay, and in the claim it said that there's no difference in college enrollment between the female population and the male population. Okay, so no difference means is that the two proportions are equal. Okay, so we're going to use the equal to symbol in the null hypothesis, right? So if there is no difference between college enrollment between female high school graduates and male high school graduates, it means the difference between the two proportions is equal to 0. Okay, so then what symbol do we use in the alternative? It's going to be the opposite. Okay, so the opposite symbol of equal to is not equal to. Okay, so if there is a difference, right, it means the difference between the proportions is not equal to 0. Okay, so then which one of these is the claim? Okay, so remember no difference means equal to. It means the two things are equal to each other. So the claim would be the null hypothesis in this case. Okay, and because we use the not equal to symbol in the alternative, right, this makes this a two-tailed test. And we'll need that information to find the critical values of this test. Okay, in any case, let's go back to the problem. Okay, so the claim is that the proportion of female college enrollees is the same as, right, or equal to the proportion of male college enrollees. Remember, the question is asking, identify the claim and state the null and alternative hypotheses. Okay, so we're going to select the correct null and alternative hypotheses. So again, P1 minus P2 equal to 0 means the two proportions are equal. So we're going to look for the answer choice where where the null hypothesis has the two proportions being equal. Okay, and then likewise P1 minus P2 not equal to 0 is equivalent to saying that P1 is not equal to P2. So it looks like answer choice F is the best answer choice. Okay, so now part B where you're asked to find the critical values. Okay, so for the problems in section 8.4, right, we're going to use the normal distribution calculator and stack crunch to find the critical values. Okay, so when we use the normal distribution, we don't need to know the degrees of freedom. Okay, like we did with like we did in the previous section. Okay, so with the normal distribution has no degrees of freedom. Okay, so we don't need to know that. But we need to make a note of the significance level, which is 0.09. Okay. So let's go to stack crunch. Okay. So when we use the normal distribution calculator to get the critical values, right, go to the stat menu, select calculator, select normal. Okay. Select the between option because this is a two-tailed test. All right, you're gonna leave the mean and standard deviation as 0 and 1, I believe. Okay, if not, we may need to update the standard deviation. But let's go ahead and leave the mean and standard deviation as 0 and 1. Okay, and we're going to type in this box here 1 minus the level of significance, so 1 minus 0.09. And you can put that in the calculator to get the specific number, but I'll leave it as 1 minus 0.09. So the critical value on the left side will appear here, the critical value on the right side will appear here. And again, once again, because the normal distribution is symmetric, right, these critical values will be the same number, but one is negative and the other is positive. Okay, so if we look at how many decimal places to round our answer, it says to 2 decimal places. Okay, so negative 1.69 gets rounded to negative 1.70. Likewise, 1.695 gets rounded to 1.70. So the critical values are negative 1.70 and positive 1.70. Okay, then it asks us to identify the rejection regions. Okay, so it's never going to be this option where the z is between the two critical values. Okay, if this were a left-tailed test, you would select this option, put in the critical value there. Okay, if this were a left-tailed test. Okay, if this were a right-tailed test, you would select this option and then input the critical value here. Okay, so the only other option that makes sense for the two-tailed test is this one. So z is less than the negative critical value. Okay, so the smaller critical value goes in the first box, and then the larger one goes in the second box. Okay, so now it's going to ask us for the test statistic. Okay, so what we're going to do is we're going to go back to Stat Crunch, go to the stat menu, and we're going to select proportion stats to sample. All right, we don't have the actual data, so we're going to select with summary. All right, it's going to ask you for the information, so the number of successes and then the number of observations in each sample. Okay, so going back to the problem. Okay, we see that there were 175 females, so that was the first sample. And then in the second sample, we had 150 males. Okay, but it doesn't necessarily tell us the number of successes, right? The successes being how many in each sample are enrolled in college. Okay, it tells you the percentage. Okay, so remember, earlier in the video I said that if it doesn't give you the number of successes, right, you use these two formulas here to calculate the number of successes. Okay, so x1 is equal to n1 times p1 hat. Okay, so again, according to the problem, 72% of the females were enrolled in college. Okay, so you're going to take that 72%, convert it into a decimal. Okay, so you take the percentage and divide it by 100, remove the decimal point 2 places to the left. Okay, so you get 0.72, and then you multiply it by the sample size of 175. Okay, and that'll give you the number of successes in the first sample, which is 126. Okay, likewise, for the second sample, the males, right, 60% were enrolled in college, so 60 divided by 100 is that number there, and we're going to multiply it by the number of males, which is 150. Okay, so the number of males enrolled in college was 90. So we're going to enter that information into StatCrunch. So 126 for the females, and then 90 for the males. Okay, and we'll go ahead and finish this example in the next video.